we're going to discuss how to solve a system of quadratic equations. Now, the ones we're going to look at today are either going to be a quadratic and a linear, or you could possibly have two quadratics, but I have not provided any videos of that. So the first one we're going to look at is y equals x squared minus 2x minus 1, and y equals negative 2x minus 1. Now, the first equation is what we call standard form of a quadratic. It might be helpful that if you have a foldable that goes along with this to look at standard form. That way you can see how to graph it. Now, if you don't have some sort of notes about this, I will kind of go through the steps. We are going to graph by transformation. So for the first thing I do is in order to graph, we need to have a vertex. So to find the vertex or the x value in the vertex, we have to use an equation in standard form. The equation is x equals negative b over 2a. So just like with the quadratic formula, a is your leading coefficient, b is your coefficient with your x, and c is your constant. So when I substitute negative b over 2a in, I get 2 over 2, and I calculate that to be 1. Next, in order to find the vertex, I not only need an x value, I need a y value. So I take that x value, and I substitute it into that exact same equation everywhere I see x. Then I use my brain or calculator, and I substitute it in and find the answer to be negative 2. What that means is that my vertex is that 1, negative 2. Now, to graph the rest of this, we're going to use the stretch, which is our leading coefficient, which is a 1. It's neither a stretch nor a shrink, but multiplying by 1 will keep it the same as it is to begin with, the parent function. So I pick some numbers, 1, 2, and 3. I square those, and then I multiply them by that a value, 1, 4, and 9. Now, if you remember back, the middle is the part we do not look at. So my transformation is going to be done from my vertex. So I'm going to go 1 out and 1 up both directions. And then I'm going to go 2 out and 4 up, and then I'm going to sketch in a quadrilateral. Now I'm going to repeat the process with the second one. Now the second one is not a quadratic, and the way I would know that it's not a quadratic is because there is no x squared in the problem. This is in the form y equals mx plus b. Oh yes, you know it, slope-intercept form, where the number in front of your x, your leading coefficient, is your slope, and the number at the end is the y-intercept. So to graph this, I started at negative 1, and with a slope of negative 2, it's rise over 1. I went down 2, right 1, down 2, right 1, down 2, right 1, and I drew in that line. Now you have to be precise when using this way to calculate solving systems. Now, if you have struggles with slope-intercept, you can always just pick some x values, put them in a t-table, plug them into your equation, such as negative 2 times 1 minus 1, and get those and plot those points, which I've also done as well, so you could see that. You don't have to use both methods, but some people find it easier just to plug in some numbers. Now, the goal of this problem is to figure out where the two graphs intersect, which is right here, and that point is 0, negative 1. That is the solution to this system. That means if I put 0 into both of these equations, it will yield negative 1 as an answer. That is the only solution to this problem. Sometimes we'll have one solution, sometimes we'll have two solutions, and sometimes we'll have no real solution. Let's look at another example, but this time our quadratic is going to be in a different form. This time our quadratic is going to be in vertex form. Now, if you look at the first equation, I see parentheses and a square. That should right away send up a blinking light to you mentally that this is vertex form. So to graph in vertex form, we start by setting what is inside the parentheses equal to 0 and solve. That will tell us our horizontal translation. So if I set x plus 2 equal to 0 and solve, it's going to be x equals -2, which means it's going to go 2 units to the left. Now, I also need to know how high my graph's going to translate. To figure out that value, I can either look at the end, which is the constant, or realize that is found by substituting in -2 into the equation provided. Either way, when substituting in -2 and doing the math using the order of operations, the answer is a 3. So this time my vertex is at -2, 3. So I plotted -2, 3. Once I plotted -2, 3, I had to figure out my stretch. In this case, though, it was 1/2. So it's not really stretched, it's compressed. Okay, that means it's going to be fat and wide compared to our parent function. So then I picked numbers. Now, if you noticed here, I picked 1, 2, and 4. The reason I pick 1, 2, and 4, or mostly 2 and 4, is it's easy to take half of an even number. So now I complete my transformation by doing my stretch. So 1 squared is 1, times 0.5 is 0.5. 2 squared is 4, times 0.5 is 2. 4 squared, 16. Half of that is 8. So from my vertex, I'm going to go 1 out, a half up. Then I'm going to go 2 out and 2 up. Now, if I needed to, I would go 4 out and 8 up, but it really doesn't fit on my graph, so I just kind of stop there. For my second equation, I looked and I said, hey, it's linear again, but it's written in standard form. So I started by rewriting it in y equals mx plus b by adding the 1/3 over to the other side. This gave me the equation y equals 1/3 x plus 1. So to plot this, I started at 1. I rose 1, ran 3. The reverse or the inverse of rising 1, running 3 is go down 1, left 3. Now, just like before, if you do not like slope-intercept, you can always just pick points. I picked factors of 3 because my fraction was a 3. So I plugged in -3, I plugged in 0, and I plugged in 3 into my equation using the substitution property. I evaluated it and found the answers to be 0, 1, and 2. Just like with my graph, it's been plotted -3, 0, 0, 1, or 3, 2. I drew my line and then I noticed, hey, these things are never going to intersect. It's kind of like when we did linear systems, you would have parallel lines that would never intersect. So then, since they have no point of intersection, what we say is it has no real solution. So we've done 2 examples so far. One with 1 point of intersection, one with no real solution, and the last one we're going to talk about is going to have, of course, the other type of scenario, 2 real solutions. For this one, I went back to standard form. Now, if it's not wrote in y equals form, you need to move everything away from the y and get y by itself. So I got that. I said, hey, there's no parentheses, so it's standard form. So I do -b over 2a. So my b is 4, my a is -1, so that becomes -4 over -2. And -4 divided by -2 is a +2. Just like with the other methods, I then substituted it in, but there was no place. Wait, hold on. Got an error there. This doesn't apply. That was my last copy for my last example. Okay. Wait, yes it does. I'm having a brain fart. I apologize. So I substituted in the 2 into my top equation and evaluated and found 1 as an answer. So 2, 1 was my vertex. Then using my table, I used a stretch of -1 because my a value was a -1. I graphed it, 1 out, 1 down, 1 out, 2 out, and 4 down, and repeated the process. I even did 3, -9. Now to graph the other equation, it just says y equals -8. Now slope-intercept, what that means is you have a y-intercept of -8 and a slope of 0 because there is no x, which means it's completely flat. If I would picked values and I plugged them in, it didn't matter what it was because the answer would always be -8 because it says y equals -8. So I graphed the line, and then I looked for the points of intersection. This time it hit twice. It hit right here on the left and right here on the right. Those points are -1, -8. Got my negative in there. And 5, -8. Now, what that means is if I put both of those back into both of these equations, those are the only 2 points of intersection. So if I put in a -1, I should get a -8. If I put in a 5, I should get a -8. And those are the only 2 values that give you that. I hope this has been helpful. Let's get started on your assignment. Thanks.